very important function that you need to be able to pretty much know inside and out is the absolute value function. So we're going to want to graph y equals absolute value of x. I'll let you work on this yourself, so go ahead and pause the video. Decide if these numbers are going to work. A lot of times they do work, but every once in a while, as we've seen, they're not the best choices. But I'm going to let you decide about that and go ahead and plot your points to try to get an idea of what you think the graph needs to look like. So you should have gotten 2, 1, 0, 1, 2 for your y values. All right. Just the dots alone are going to look like this. Then we have to think about how to connect these dots. Would it make sense to connect these using like line segments or array or a curve of some sort? What kind of exponent do I have on my x? This is the x to the first power. All right, and if you look at the numbers that you were getting, you had 0, 0, 1, 1, 2, 2. They're lining up perfectly. You could continue. You would have 3, 3, 4, 4, etc. So these are going to line up in a linear fashion for us. And this is going to create a V-shaped graph. Okay, so I tell people to help them remember, when you're trying to remember which equations have which graphs have which shapes, if you think about the V, absolute value has a V shape, hopefully that will help you to remember that's what it's supposed to look like. And of course you can still graph it on the calculator, but you really need to be able to know right away. Absolute value is a V shape. So this is what my graph looks like. What is my domain? Negative infinity all the way to positive infinity. We're back to these arrows, and they go forever in both directions. What do you think my range needs to be? Starting down here, the graph does not come below the x-axis. It only begins here when y equals 0, and then it goes up to positive infinity. So the range would be square bracket 0, comma, infinity. The next thing we're going to talk about are piecewise functions. As the name suggests, a piecewise function is graphed in pieces, essentially. It's going to be defined differently depending on where you are in the domain. For example, maybe if x is less than 4, meaning that I'm going to be like from here back, my function might be doing something up here. But maybe when x is greater than 4, so on this side of the graph, it might be doing something completely different and somewhere down this way. And it can also be, it could look like a parabola in one portion of the graph, and then it might switch over to like a straight line in another section of the graph. So we essentially are just taking the increments of different graphs and putting them together and to create a piecewise function. We've got 2 examples that we need to do. So we want to graph f of x equals, this is going to be 1 if x is less than 2, and then it's going to be defined to be negative 1 for x values greater than or equal to 2. So I'm going to look at my t-table, and I'm going to start putting numbers in for x. Students always ask, how do I know what to put in for x? Well, I tried to look at this piece of my definition for this problem. I know that the function is doing one thing on one side of 2, and it's doing something else on the other side of 2. So when I do my t-table, I need to put in a few values on each side of the number 2. So, and again, it's because this is where the change is occurring around x equal 2. So I need to put in, I'm going to put in negative 1, 0, and 2. Let me do that again, I'm sorry. Let's put in 0, positive 1, and 2. And then put in a couple of numbers that are bigger than 2, so 3 and 4. But general rule of thumb here is I need that kind of middle number in this list to be where this change occurs, where they change around x equal 2. All right? So this tells me that starting with x equal to 0, if x equals 0, I have to decide if I'm going to be looking in the top piece or the bottom piece of my function. Well, x equals 0, if I put it here, 0 is less than 2, that's true. So that means I'm going to use this definition. I'm going to use 1. So so if x is less than 2, y, my function value will be 1. So I can put a 1 right here. If x equals 1, again, I have to decide, do I go to the top or to the bottom? If I've got 1, 1 is still less than 2, so that puts me here. So this is my function value, so 1 there as well. If x equals 2, this time I'm looking at the bottom. If x equals 2, I'm going to use this definition. So my function value is -1, or my y value will be -1. If x equals 3, 3 is greater than 2, so I'm going to use this part. I'm going to use -1 for my y value. If x equals 4, still going to be here. 4 is greater than 2, so my function value, or my y, will be -1. So now we can plot those points. X equals 0, y equal 1 will be here. Order pair 1, 1. Going to be here. Order pair 2, -1, so over 2 and down 1. Order pair 3, -1 is here. And 4, -1 puts me here. So I've got 2 flat lines, basically. All right, on the left, so we've got the dots in here. How are we going to fill this out? Again, the graphing calculator can help you with this, so that you can use that as an aid. But doing this by hand, how do I fill in these pieces? If you want to see what's going on back here, go ahead and put in some negative values for x. If you put in -1, what would you get for y? Well, if you put in -1 for x, that puts you in this piece because -1 is less than 2, so you would get +1 for y. So that would give you this. If you came back here and said, I don't know, if x equals -4, that still puts you in the top, so you're going to get +1. So if you put more in, you can see that all this is going to go back to -infinity. This is a flat line. Over here we've got dots starting when x equals 2 and extending out to +infinity. All right, but we've got a little bit of a gap here. My function is defined up to x equal 1, then I've got a space, and then x equal 2 is doing something else. So I've got to make sure that I have everything in here included in my graph. So what if I'm between x equal 1 and x equal 2? What happens? So let's say if I put in 1.5. If x equals 1.5, 1.5 is still less than 2, so y would be 1. So if you want to write that on here, if I put in 1.5 for x, my y is going to be 1. So 1.5 on x, 1 on y gets me there. And you can put in other numbers that are closer and closer to 2, like if you put in 1.8 or 1.9, it's going to get closer and closer up to x equal 2. However, if x equals 2, that's when it jumps down here. So we want to show that it's going to get all the way up to the 2, but it's not going to include the 2. And we can show that with an open circle at the 2 and extend the line like this. Okay? So that's what my graph would look like. It's going to be a flat line going through y equal 1 until I get to x equal 2. Then I've got the open circle, it jumps down, and then it's going to be at y equal -1, and it's going to stay there. Why do I need to put in that open circle? Well, with this being a function, it does still need to pass the vertical line test. And the open circle allows it to pass the vertical line test, because regardless of where I put my vertical line, remember my vertical line is only allowed to touch my graph one time. And with the open circle, it only touches the graph once when x equals 2. For 7b, we want to graph f of x equals x squared minus 4 for x between -2 and +2, or x minus 2 for x greater than 2. So this time, I think just like the last one, 2 is where the break occurs in the graph, yeah. So again, when x equals 2, the graph is doing one thing over here and it's going to be doing something different over here, or maybe it's down there. So when I go to fill in my x column in my table, I look at where the change occurred right here at the 2. And if you want to put in a -2, that's good too, that's fine. But I need to put in numbers on each side of +2 so that I can show whatever, so that I can make sure that I need to be able to see what's going on around x equal 2. So I'm going to put 2 in the middle, and then I can put maybe a 0 and a 1, and then over here a 3 and a 4. And I may have to put in more to get a good picture of what's going on with it. So when x equals 0, again, am I in the top or am I in the bottom? Well, 0 is between -2 and +2, so that means I need to be in the top. I put 0 here for x, I square it and subtract 4, so my y value is -4. When x equals 1, that's going to still put me up here because 1 is still less than 2. 1 squared minus 4 gives me -3 for my y value. When x equals 2, where am I now? All right, so if x equals, pay close attention to these inequalities. This says the top one x is less than or equal to 2, and then here x is greater than 2. So whatever number you're working with, it's only going to fit in one spot. So if x equals 2, I have to be up here still. So put 2 here for your x. 2 squared minus 4 would give me 0. When x equals 3, now I'm in the bottom because 3 is greater than 2. 3 minus 2 gives me 1. When x equals 4, 4 is greater than 2, so I'm in the bottom. 4 minus 2, my y value is 2. Okay, and now we can plot our points. We've got order pair 0, -4. Order pair 1, -3. 2, 0. 3, 1. 4, 2. Okay, now the dots are really not enough by themselves to tell us how to connect the dots or how to draw our graph. So you can always add more points. You can substitute more values in. I didn't come back here, and I would like to know what's going on the left side of the y-axis. So let's put in -1 and a -2 for our x. Let's see what we get. If I put in -1, where does that put me now? -1 is here. So I'm going to do -1 squared minus 4. So 1 minus 4 is -3. And if I put in -2, -2 is as far down as I get to go because that's the last number that's in the domain. If I put -2 here and square it, I get 4 minus 4, I get 0. All right, so -1, -3, find that ordered pair. It's here. And I want to find ordered pair -2 zeros here. Okay, so this is a good example of why it's important to know the shapes of the graphs that you're working with. Look at our original problem. We're asked to graph this x squared minus 4. That's the x squared, all right? And again, this is from -2 to +2. So between -2 and +2, in between these two numbers in this area, based on the function that I'm given, what should be happening with my graph? If I just look at this much of it, I've got these dots, like this, and that comes from the x squared function. So that is enough information to tell me how to draw it. With it being an x squared, it should be a parabola, so I can connect these dots using a parabola. And my graph is not perfect. It should be a little bit more like this, because my dots did not come out looking like a parabola. They look too straight. They look too much like a V. But it needs to be a parabola, because it's an x squared. So that's part of it. All right, so when x is greater than 2, what does it look like is happening over here? Well, now it looks like they're lining up in a straight line. Does it make sense? Let's go back and look at the function. When x is greater than 2, the function is defined to be x minus 2. Well, that's x to the first, which is just a straight line, so that obviously matches with what we've got here. So for any value of x greater than 2, so it means we're going to go out this way forever, we can go ahead and connect those dots and put an arrow indicating that it continues to infinity. Should there be anything back here? Why didn't I put an arrow on this piece? I've just got a dot. Well, that's because they told me that the function was defined beginning at -2 up to +2, and then it was defined for anything larger than +2 this way. So I need to just have a dot here, but not an arrow. But that's what my graph looks like. So you can see how this piece came from the x squared function because it's a parabola, and this piece is just a linear function because it's a straight line. What if let's go ahead and practice with domain and range. What if we were asked to find the domain for this? What would it be? With your domain, you're going to go from the left to the right, looking for all possible x values. I'll give you a hint. You can also find the domain from looking at this up here. But just looking at the graph begins here when x equals -2. And then it continues all the way out to positive infinity. All right, it includes that -2, so we'll put a square bracket, -2, comma, infinity. And then for your range, we're going to start at the bottom. The graph begins right here when y equals -4, and then it goes up to positive infinity, because the arrow goes up forever. So square bracket, -4, comma, positive infinity. So it's just a little practice for domain and range. We're asked to determine whether our function is increasing, decreasing, or constant. Okay, what is that? That essentially means that, and I'm sorry about my, the camera has changed and now you can only see my head. What that means is as x increases, what's happening with y? So on your graph, as you move from the left side to the right side, are your y values going up or are your y values going down? The easiest way to see this visually is that as you're going from the left to the right, and imagine if you're on this actual graph itself, as you go from left to right, are you going uphill or are you going downhill as you go along this graph? Okay, on this one you're going uphill, so this one is increasing. In part B, as your x values increase, as you go from the left to the right along the domain, what's happening with the y values? So if I come back here, as I move from the left to the right, going along this graph, I'm going downhill, so this one's decreasing. And then finally, part C. All right, here you've just got a constant function. It's flat. So as your x values increase, as you go from the left to the right on this graph, you are not going up or down, you're just staying in the same place. So this one is constant. So as the x values increase, the y values stay the same. So it's just a flat line, this one's a constant function. And that is it for section 2.2. So again, make sure that you understand that you have to, okay, I hope you can see that okay. Let me go adjust the board real quick so you can see it. Make sure that you remember that when you're working with section, those functions that we discussed, you are responsible for being able to recognize them just based on their equation. So you're going to need to remember that an x squared function is a parabola. An x cubed function is this like S shape. I call it an S shape. I don't know what else to call it, but it's a parabola that one side is flipped upside down, basically. And then you have to know what your square root function looks like, your cube root function looks like. You need to be able to recognize when you've got working with a semicircle. So the semicircle equations will be like a square root of a constant minus x squared. You just have to be able to recognize it when you see it. And absolute value function, you've definitely got to make sure that you know what the absolute value function looks like as a V shape. Okay, so work on these problems. We will be discussing these in class, and good luck with section 2.2.